Hi guys, Terry here again. In this video, I'm going to be looking at the solution to the question 8 in the January 2021 paper, right? Alright, so in this one here, we have a straight line intersects the x-axis at P and at Q, right? Determine the coordinates of P and Q. Now, so if you remember what a graph looks like, right? We have our x-axis and you have your y-axis. Your x-axis is also known as the line y is equal to 0, and your y-axis is the line x is equal to 0. Now, that's what we have to make use of when we want to find where a straight line intersects my x-axis, right? So let's look at the x-axis first, right? So at the x-axis, y is equal to 0, right? So we're going to use the formula, the equation of the line, that is. So when y is equal to 0, we're going to say x is equal to 5 minus 3 multiplied by 0. So therefore x is equal to 5 minus 0. Therefore x is equal to 5. Now they said it's cutting the x-axis at P, so therefore the coordinates of P is going to be 5, 0, right? Those are the coordinates of P. Now we need to do the same thing for your y-axis. Now in the case of the y-axis, right, x is equal to 0, right, on the y-axis. So we're going to say that when x is equal to 0, right, you're going to substitute that into your equation of your line. So we're going to say 0 is equal to 5 minus 3y. So if we solve for y, we're going to get 3y is equal to 5. So y is equal to 5 over 3. So therefore, this point Q, because they said that's where it cuts the y-axis, is given by 0, 5 over 3. So those are the coordinates of my, those are the coordinates of P and Q, right? The next part, they want us to calculate the length of PQ, right? So the length formula, right, is given by x2 minus x1 squared plus y2 minus y1 squared, and we need to find the square root of all of that, right? Now let's write down the coordinates of P and Q. So P, we got 5, 0, right? And Q is 0, 5 over 3, right? Now, before you do anything with these questions, always, and I repeat this, always label them. So I'm going to label this as x1, y1, label this as x2, y2. If you do that, then the likelihood of you making an error is going to be slim. So all we're going to do, we're going to substitute those values into the formula. So x2 in this case is 0. So it's 0 minus 5 squared plus y2 minus y1, right, which is 5 over 3 minus 0 squared, and you're going to find the square roots, right? So 0 minus 5 is minus 5, so this is minus 5 squared plus 5 over 3 squared, square root. 5 5s are 25 plus 5 over 3 squared is 25 over 9, and you're going to find the square root of this. So 25 plus 25 over 9, second function, square root, and I'm getting 5.27. So this is your answer here, 5.27, and because it's a length, we're going to put 5.27 units, right? The third part, they want the midpoint of R, right? So again, let's write down, sorry, the midpoint, they said R is the midpoint of PQ. So let's write down what P is again. So P is 5, 0, right? And Q is 0, 5 over 3, right? So again, before I do anything, please label your points. So this is x1, y1. This is x2, y2. Now, this formula is not given to you in the exam, so you need to know it. So R, they said, is a midpoint, right? So there is a midpoint formula, right, which is given by x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So basically what we are doing is adding the two x values and divide by 2, add the two y values and divide by 2. So this here is going to be 5 plus 0 over 2, comma, and we're going to add 0 plus 5 over 3 divided by 2. So this is going to be 5 over 2, comma, and this is going to be 5 over 3 divided by 2. So that's going to give me 5 over 2, comma, right? Now 5 over 3 divided by 2 over 1 is the same as saying 5 over 3 multiplied by 1 over 2, and that's going to give me 5 over 6. So this here is going to give me 5 over 6, right? So that's my midpoint there. It's going to be 5 over 2, 5 over 6, right? Now the next thing that we need to work out here, they have two functions, right? They have f of x is equal to 5 minus x, and g of x is x squared minus 2x minus 1. These two graphs meet at points m and n, determine the coordinates of m and n. Now this one here, the first one, y is equal to 5 minus x, that's a straight line, and the other one, y is equal to x squared minus 2x minus 1, that's a quadratic. So we have a quadratic, right? So the quadratic might be looking like this, and the straight line might be looking like this, and they want us to find where are those points of intersection. These 2 points are what we're trying to find here. So what they're really trying to make us do here is a simultaneous equation. So y is equal to 5 minus x. We're going to call that equation 1. The second one is y is equal to x squared minus 2x minus 1. We're going to call that equation 2. So if we're trying to solve a pair of simultaneous equation, what we typically do is substitute one into the other. The easiest thing to do is to substitute the linear one into the nonlinear one. So I'm going to substitute, right, equation 1 into equation 2, right? And therefore what I'm going to get, I can write this as x squared minus 2x minus 1 is equal to 5 minus x, because both of them equal to y. This is equal to y, this is equal to y. Now to solve this, I'm going to carry everything to the left hand side, so I'm going to end up with x squared minus 2x plus x minus 1 minus 5 is equal to 0. Simplify some more. X squared minus 2x plus x is going to give you minus x, minus 1 minus 5 is going to give you minus 6 is equal to 0. The next thing we're going to do now, we need to factorize this. So let me just write this back here. Right? So we know when we factorize this, I should get 2 brackets. So this should be an x here, and maybe a 3 here and a 2 here. And if I make this plus and this minus, let's see if that makes sense. X by x gives me x squared, so we're good. Minus 3 by positive 2 gives me negative 6. That's good. Minus 3x plus 2x. Okay, we're good there. So we can now say either x minus 3 is equal to 0. Therefore, x is equal to 3. And therefore, we can find the y value. So we substitute into the linear one, might be the easier one. So it's going to be 5 minus 3. So that's going to give me 2. So let's call that point M. They didn't tell us which one to call M, but that's okay. So M is going to be 3, 2. That's one coordinate, right? So the other solution now, we have to put x plus 2 equal to 0. Therefore, x is equal to minus 2, right? And then we're going to substitute that minus 2 into my linear equation. So it's going to be 5 minus minus 2, which is going to give me 7. So therefore, this point here, right, is going to be minus 2, 7, right? Now we don't know which one is M or N, right? But based on my simple diagram here, I'm going to label, I'm going to reverse the label it. I'm going to call this N here, and I'm going to call this M. Because of where it is, right? Because of where it is, this has to be your minus 2, the x value, and this has to be 3, right? So that's why I relabeled it there for you guys. So those are my coordinates here. That's what we're looking for, right? And the last part has to do with speed time graph. So Monty is cycling at 12 meters per second. After 4.5 seconds, he starts to decelerate, and after further 2.5, right? So we have a speed time graph. First thing they want what is the constant deceleration. Now, this is a speed time graph. So all we need to do to find the deceleration, right, is to find the gradient, right? So we need to find the gradient of this line here, right? So in order to find the gradient, all I need to do is to get 2 points. So this point here is 4.512. This point down here is 70. So I have 2 points, and I'm going to use those 2 points to find the gradient. That's going to allow me to find the acceleration, right? It is going to be negative because of how the graph is sloping. I'm slowing down. So 4.512. So these are my points, 4.5 and 12. And the second point, I think, is what? 70. This here is 70, right? So before we do anything, we label. So this is x1, y1. This is x2, y2. And what we're going to do is to find the slope or the gradient, right? So the gradient, right, that gives me my acceleration, right? And the formula for gradient is y2 minus y1 over x2 minus x1. In this case, it's going to be 0 minus 12 over 7 minus 4.5. So that's going to be minus 12 over 7 minus minus 4.5 is going to give me what? 2.5, right? So this here is 2.5. So minus 12 divided by 2.5, and you're going to get 4.8. So this here is negative 4.8, and its acceleration, so it's meters per second squared, right? Now this is my acceleration. The question says, what is the deceleration? So all we need to say is the deceleration, right, is equal to the positive value, which is 4.8 meters per second squared, right? So that's your answer for that part. The next part, they want Monty's average speed over 7 seconds. So speed, so average speed is equal to distance, your total distance, over time, right? So in that 7 seconds, right, we know the time frame is 7 seconds, so the bottom of this formula has to be 7, but we need to know the distance. That's what we need to know. Now, to find the distance traveled from a speed time graph, what we need to do, we need to find the area under this whole graph here, right? We need to find the area. So there are two ways we can find the area. That shape there looks like a trapezium, right? So I can use the area for trapezium there to find the distance, or I can break the shape up into a rectangle and a triangle. It's up to you all, right? So I'm going to use the formula for a trapezium. So from here to here, that distance there is 4.5, right? The distance at the bottom here is going to be 7, so that's 7, and the height of this thing here is 12, right? Now there's a formula to find the area for trapezium, which is given by a half by the sum of the parallel sides multiplied by the height. I have all the information needed to do that. So area of trapezium, right, is given by a half multiplied by a plus b multiplied by h. So it's a half multiplied by those two lengths, which would be the 4.5 and the 7. So that's 4.5 plus 7, and you're multiplying that by your height, which in this case was 12. So this here is going to be 12, right? So when I work that out, let's add 4.5 plus 7. I'm going to get 11.5 multiplied by 12 multiplied by a half, and I'm going to get 69. So this here is 69 meters. So all I'm going to do is to take 69 and divide it by 7, and I'm going to get about 9.86. So this is average speed, right? So it's meters per second. Now some students may write their answer as 9.8 m/s. That's also acceptable, right? So that brings us to the end of question 8, right? Like I said, hit like and subscribe, right? Thank you guys for watching.